In this video, I will show you a 2D high-speed dynamic core mill toolpath. This generates the free-flowing motion needed to machine features, such as standing bosses and cores, in a single operation. First, remove the toolpath display from your screen. To do this, press Alt-T on your keyboard. Also, select the isometric view to view your part more clearly. Select Toolpaths, 2D High Speed, Dynamic Core. When the chaining dialog box appears, leave the default settings. Select the first rectangle as shown. Then choose the outside edge of the part as shown. This chain represents the profile which we want to machine to. Once both chains have been selected, choose the OK button to exit the chaining dialog box. Again, select the OK button to exit the Chain Options dialog box. In the Toolpath Type page, the Dynamic Core Mill will be selected. We will now choose a chatter-free 1-inch flat end mill from the library and set the tool parameters. From the Tree View list, choose Tool. Click on the Select Library Tool button. Click on the New Library button. Select the following and then choose the Open button. From here, select the Filter button. Select None, and under Tool Types, choose the Flat End Mill icon. Under Tool Diameter, pick Equal and input a value of 1. Once your parameters appear as shown, select the OK button to exit the tool list filter. In the Tool Selection dialog box, you should now only see two chatter-free 1-inch flat end mills. Select the first tool and choose the OK button. Your tool will appear as shown. Enable ISCAR HEM and change the HEM factor. From here, input the following comment: machine the outside profile using Dynamic Core Mill. Once the comment has been entered, select the cut parameters. Change the approach distance to a value of 0.5. Also, change the amount of stock to leave on the walls to 0.02. Finally, change the percentage of tool diameter to 500. The rest of your parameters should appear as shown. Before we move on, disable the option to optimize cut order within Pocket. You can now select the depth cuts. Ensure that this option is disabled. From here, select the entry motion. Ensure that the entry method is set to helix only. Now change the helix radius to a value of 0.95. Also, change the Z clearance to a value of 0.05. The rest of your parameters should appear as shown. You can now select the breakthrough. Ensure that this option is enabled and input a breakthrough amount of 0.1. Once complete, select the linking parameters. Input a depth value of absolute negative 1.25. The rest of your parameters will remain as shown. You can now select the OK button to generate the toolpath. We will now backplot and verify the operation to ensure that the tool motion is correct. Select the backplot icon. Ensure that Tool and Workpiece are enabled. Now select the Fit icon and press the Play Simulation button. Your toolpath will appear as shown. You can now exit Backplot. From here, select all of the operations and verify the part. Ensure that Tool, Stock, and Workpiece are enabled. Now select the Fit icon and press the Play Simulation button to run Verify. Your part will appear as shown. You can now exit Verify.